You think the sun is massive. You could fit 1,300,000 Earths inside it. Jupiter is over 1,300 Earths. That sounds smaller. It is smaller, but here's what they don't tell you. Jupiter tried to become a star. It ate everything in its path. Dust, gas, rock. It kept growing, kept pulling. It wanted to ignite. It wanted to burn. And then at the last moment, just 1% short of fusion, it stopped. So what do you get when a star refuses to wake up? You get a bomb that never went off. You get a planet that isn't really a planet. And if you fell into it, there would be no ground to catch you. You would just fall forever. Every planet has a surface. Mars, red rock and iron dust. You could stand on it. Venus, volcanic plains hot enough to melt lead. Deadly, but solid. Even Saturn. If you could somehow survive the descent through its clouds, you'd eventually hit something. Somewhere deep down, there's a core. Jupiter has no surface. Think about that for a second. No ground, no rock, no place where the falling stops. 99% hydrogen and helium. The exact same recipe as the sun. The exact same ingredients that make stars burn. But Jupiter never lit the match. So when you fall in, at first it looks almost normal. White clouds, ammonia ice crystals, negative 150 degrees Celsius. Cold, but not impossible. You keep falling. The clouds turn brown. Sulfur compounds mixing with the hydrogen, then rust red, phosphorus, then orange, then black. And you're still falling. But now it's not gas anymore. The hydrogen is too compressed, too thick. It turns into liquid. You're not falling through air. You're sinking through an ocean of hydrogen. An ocean with no bottom, no surface above, no light, just pressure. And it keeps building. Deeper still, the pressure gets so extreme that the hydrogen forgets how to be a liquid. It becomes metal, not solid metal, not liquid metal, something in between, a conducting fluid, metallic hydrogen. Electrons ripped free from atoms flowing like electrical current. An ocean of liquid metal generating a magnetic field 20,000 times stronger than Earth's. This ocean is larger than our entire planet. And it's been down there for 4.5 billion years. This is what happens when a star gives up halfway. The Great Red Spot, 1665. That's the year Giovanni Cassini first spotted it. A red oval, a blemish on Jupiter's surface. He didn't know what it was, just something that shouldn't be there. 1830, still there. 1979. Voyager 1 photographs it. 3 Earths wide. Winds screaming at 400 miles per hour. A hurricane that makes every storm on Earth look like a breeze. 2025, still raging. Empires have risen and fallen. Species have gone extinct. We invented electricity, flight, the internet, and that storm just kept spinning. But here's the thing, it's shrinking, losing about 580 miles in diameter every year. Nobody knows why. In 100 years, maybe 200, it might be gone. And we have no idea what happens when a 400-year-old storm finally dies. We've never seen one end. Jupiter kills from millions of miles away. Its magnetic field is the largest structure in the solar system. If you could see it, it would stretch from Earth to Mars. Trapped inside that field are radiation belts, high-energy particles, electrons and protons accelerated to 99% the speed of light, bouncing between Jupiter's magnetic poles. They've been building up for 4 billion years. Earth has radiation belts too. The Van Allen belts, peak radiation there, about 1,000 rads. Jupiter's radiation belts? 20 million rads per orbit. Jupiter delivers a lethal dose in 3 seconds. Now think about Europa, one of Jupiter's moons, covered in ice, possibly has a liquid ocean underneath, could have life. But Jupiter's radiation hits Europa with 540 rems per day. That's 100,000 chest X-rays every single day for 4 billion years. We're searching for life on Europa, while Jupiter is sterilizing it in real time. Any life that exists there isn't thriving despite the radiation. It's hiding from it, miles under the ice, in the dark, in the only place Jupiter's fury can't reach. The king doesn't protect his kingdom. He poisons it. But here's the thing that doesn't make sense. We might owe Jupiter our lives. July 1994. A comet called Shoemaker-Levy 9 breaks apart into 21 fragments. Each fragment the size of a mountain. They slam into Jupiter. The explosions are visible from Earth. Fireballs 3,000 miles high. Scars on Jupiter's surface the size of our planet. If those fragments had hit Earth, extinction. No question. Computer models have been running for decades, simulating asteroid trajectories, calculating odds. The math says Jupiter's gravity catches about 1,000 asteroids for every one that reaches the inner solar system. For 4 billion years, it's been pulling danger away from us. A cosmic shield. But the same simulations show something else. Jupiter also throws asteroids inward. Gravitational slingshot, chaotic orbits, the three-body problem, no perfect solution. The numbers don't add up cleanly. Jupiter blocks roughly 60% of potential impacts, but Jupiter also causes about 10% of actual impacts. Net protection, 50%. So here's the question nobody can answer. The asteroid that killed the dinosaurs, Chicxulub, 66 million years ago. Did Jupiter catch it and miss, or did Jupiter throw it at us? We don't know. The math is too chaotic. The three-body problem has no clean solution. We can simulate, we can estimate, but we can't rewind time. Jupiter might be our guardian. Jupiter might be our assassin. Most likely, it's both. And we'll never know which version saved us, or which version will kill us next. Jupiter is a catalogue of almosts. Almost became a star, stopped at 99%. Almost protects us completely, but also threatens us. Almost kills everything that gets close, except its moons somehow survive. In 5 billion years, the Sun will become a red giant. It will swallow Mercury, Venus, probably Earth. Jupiter will still be here, still spinning, still crushing, still generating a magnetic field strong enough to break physics. We live in a solar system of accidents, a star that almost ignited, an asteroid belt that almost became a planet, a Mars that almost kept its atmosphere, an Earth that probably should have been hit 1,000 times by now. Everything here is an almost. Jupiter doesn't care what we call it. Planet, failed star, radiation hell, protector. It just keeps doing what it's always done, spinning at 28,000 miles per hour, crushing hydrogen into metal, trapping radiation for eons. Not a planet, not a star, just an unfinished thing, that happens to be 1,000 times more massive than everything else we know, combined.